Hey guys, thanks for joining. Good afternoon, everyone. And again, thank you for joining again for our webinar on performing paperless calibrations with ProCal and documenting process calibrators. Really excited to have you guys here today. This is, one of our real wheelhouse topics. I think it's really important to a huge portion of our customers. Bob's a great expert for us, so we're really excited to bring this material to you today. So if you don't know me, my name is Michael Price. I'm Prime Technologies Director of Customer Success. I've been a ProCal implementation specialist here since 2011. I've helped lead software implementations, big and small, in a variety of industries: pharma, food and beverage, oil and gas, many others. Today, we're going to be talking about performing paperless calibrations with ProCal and document process calibrators and all the benefits that solution brings to your daily practices. We're going to be staying pretty high level on this topic. You'll notice you have a Q&A, a questions button down at the bottom of your screen, on which you can ask questions during the presentation. We're going to have a Q&A period at the end of the webinar, and we'll focus on getting those questions answered then. But don't hesitate to drop them in any point. If we don't get to your question, I'll personally follow up with anybody who we don't get to specifically address your question after the webinar. This will also be recorded, and we'll share a link with the recording after we're done. Excited to get started. So also with me here is Bob Kreps, and Bob's been a long-time trusted partner of ours at Prime. He's with Fluke Corporation. He's one of their leading experts in their process tools group. Bob, would you like to introduce yourself?
Yeah, sure thing, Mike. Yeah, Bob Kreps. I'm the product specialist for the process tools group at Fluke Corporation. I've been working in the industry a long time, but for the last decade, I've been with Fluke, specializing in process tools, do a lot of tech support training. And today I'll give you guys a demonstration of what you do with the task after it's been created with the ProCal software. Okay, Mike.
Great. Thanks, Bob. So like we said, today we're going to discuss how you can use an electronic calibration management system like ProCal to drastically reduce the amount of time it takes to perform and record your calibrations, while also improving the accuracy and reliability of your records and calibration certificates by eliminating the need for paper-based hard copies. We're going to talk about how you can take that efficiency even further by introducing the use of these Fluke calibrators, which again communicate directly with ProCal to manage and record your calibration activity without the need for a laptop or a tablet out in the field or out on your production line in your facility. And then, like Bob said, he's also going to provide us with a hands-on demonstration with how these calibrators look and feel with a temperature transmitter. And once again, we're going to have that Q&A period at the end. So drop your questions in there with your question button down at the bottom. So during my years here at Prime, I've traveled all over the world to customer facilities for training and manage implementation projects. Some of these facilities include state-of-the-art factories, food production plants, breweries, power plants, you name it. I've always been impressed by the technology and the planning it takes for these facilities to run and operate. But at the same time, I've been surprised over and over again by how many of these high-tech facilities still rely on good old-fashioned pencil and paper to document and store their calibration activities. Even some of the largest companies I've worked with that are on the cutting edge of technology in their respective industries, they're still documenting their calibrations on paper worksheets and storing those worksheets in filing cabinets for future reference. And when an audit happens and they're asked to produce proof that an instrument or a piece of equipment was calibrated, many of you calibration professionals I've seen are still forced to dig through an overstuffed filing cabinet to locate an old certificate or worksheet. It just takes a lot of time. So that's what we're talking about today. When we've helped customers move their calibration activity from a paper-based system like that to ProCal, the efficiency gains are immediate and obvious. Like most digital tools out there that you might have used, ProCal allows you to obviously save time and reduces the potential for mistakes that are pretty easy to make when you're using paper and reading handwriting. But even without the use of a calibrator, using ProCal to electronically schedule and record calibration results, again, it just saves a tremendous amount of time. The results can be entered directly into the application while you're out on the floor. It removes the need to transpose that information from paper into the software, which obviously opens up the opportunity for mistakes. Biggest advantage I've seen when customers move to a paperless workflow ProCal is, obvious. It's the no more filing cabinets. No one likes those. So, ProCal allows you to record your calibration results electronically and generate that calibration certificate on demand at any time, no matter how long ago the calibration took place. So you no longer have that need to store your paper, whether it's your, calibration results themselves on a worksheet, or a certificate that you have to put together to document the activity for later reference. So with that said, introducing a calibrator to the workflow leads to even more time saved. Previous analysis done by us at Prime and Fluke shows the amount of time can be reduced by as much as 75% for calibration activity. Documenting process calibrators like the Fluke 754 or the 729, or these handheld devices like you see in the picture there that can store the calibration specifications and source the inputs while simultaneously capturing the readings, and then saves those results. And then those results can be uploaded automatically to create that electronic calibration result record in ProCal. That upload process allows users to review each calibration result either one by one or approve it as a batch. And then you can even also load in extra prompts to be to be populated either before or after the calibration event. Things like atmospheric conditions, calibration type, man hours, reason for failure, several others. In ProCal, each individual instrument is configured with its own calibrator options, including things like loop power settings, delays, reading methods, custom unit types. Now, these Fluke devices, they function great on their own, but their capabilities are greatly expanded when you're sourcing those specifications directly from ProCal to the calibrator memory. Then when you perform your calibration in the field using minimal extra equipment, and there's no need to bring your laptop or other computer or tablet out into the field with you. You can just operate solely on that calibrator device. So our most common types of calibrations are going to be temperature and pressure. Those are the two most common types we see over and over again that are performed with a calibrator like the 754 or the 729. The most valuable use cases we see are the ones in which the DPC can be used to simulate the sensor, something like a thermocouple type K output, and then measure the 4 to 20 milliamp loop output while simultaneously supplying the 24-volt loop power to power that transmitter device. And it's even better when you can add in extra settings like the sensor trim and heart settings that are sent to the unit under test during the adjustment period, or using that 754 or the 729. Another common use case is those pressure calibrations where you're using a pressure module that is built for a specific pressure range, or if you're using the 729, which is going to automatically do the pumping for you, and then also, again, capture that 4 to 20 milliamp output. Third common type we see are other types of electronic controls, or controls that require a user-entered value that can be entered directly onto the calibrator itself, like an indicator or pH meters, things like that. And again, that's done in the field where the value of the calibrator is you're doing all this on one tool, capturing the data, even if you aren't necessarily measuring or sourcing from that unit. On the screen here, you see the calibration certificate, which is sort of the output that's generated after the calibration is performed and then uploaded back to ProCal. That calibration result is entered as a record into ProCal, and then these certificates can be generated again anytime, instantly, with just one click of a button for anybody that, whether it's an audit or some type of internal oversight, QA or something like that. So now we're going to get into the good stuff here, and this is where I'm going to turn it over to Bob, and he's going to throw on his camera and actually show one of these calibrations live with the Fluke 754.
Okay, thanks, Mike. So I'm going to go ahead and change the screen, take me off because I'm going to be moving over to my lab area here. So let's see if we can get this up. Okay, so here is what we've got over here is a Fluke 754, and we are connecting to a Rosemount 644 transmitter. We're providing loop power through the 4020 milliamp jacks, and also we can talk HART through these milliamp loop here. And then we're also sourcing or simulating a thermocouple signal to the transmitter, so we can do a full calibration with this setup here. So if you notice, we've got our source and measure set up. If I press the HART button, we're going to go ahead and look for a HART device out there, and it finds that 644 transmitter. It's called TT1, and you can see the lower and upper range values on here. What we're going to do next is we're going to actually do a calibration. So I'm going to press the HART button again. We're going to measure milliamp source thermocouple type K. From this screen now, what we've got is we have already downloaded some tasks from ProCal. So if I go to more choices and hit tasks, you'll see I've got a few tasks that I've downloaded, and you'll notice down here TT1, and that's this guy here. So I can bring it up, and you'll notice you can program into the from the software. You can get the information about the device so the technician knows where things are located. Also, you can send a message to the technician from ProCal. In this case, I just said verify the box is open before testing, and then we'll continue. And you'll notice, so all the information that I need to know about my calibration has been downloaded from ProCal to the calibrator. So we know that our measure is going to be 4020 milliamps. The tolerance has been set in this case to 0.5. This is all this stuff selectable by the user or the admin. We're setting up a 10-second delay because we're going to do an automatic calibration. And then on the source, to 0 to 300 degrees C. And the test strategy is how many test points that are required for the test. And again, this is determined by when you're setting up the configuration in ProCal. Okay. Now, here's a fun part. So with this calibrator, we can automatically run a test without having to do any manual stuff. So this is going to automatically source the thermocouple signal and measure the 4020 milliamp and go through each test point with that 10-second delay. So I'll hit Autotest. And so we're going to test this guy out and see what it looks like. And again, this is a 5-point test, so it's going to check at 4 milliamps at the 25, 50, 75, 100%. And you see we're going to 75 now, then we'll go to the next step up. And each one of these, the calibrator is actually capturing the milliamp value for each of these test points. So none of this stuff has to be written down. It's all automatic. It's highly accurate, and it makes life a lot easier. And I can be drinking a cup of coffee while I'm doing the calibration. So it makes it kind of nice. So once all the information has been captured in this calibration, and this is called the as found. So this is when you first bring your calibrator to the device and you connect up and take your readings. This is the as found. And you'll notice, well, this transmitter is not in too good a shape. We have a lot of inverse video, which means it's out of spec. Remember, we had it set for a 0.5% accuracy. We're over that right now. So what we're going to do is continue. And we've captured all this information in the calibrator. Now we've got the tag ID name. We're going to capture that, the serial number, and then the ID of the technician's name. Whoever did the test, it will be included. We'll continue. Now at this point, so we know we're out of spec and we need to make some adjustments. So we can go in and hit the adjust button, and you notice we can adjust the 4020 output trim. And we can also adjust the input sensor trim. So let's start with the output. So we'll hit enter. Make sure we're connected to the device. Okay. Now, if you'll notice the PVAO, this is a process variable analog output of the transmitter. The transmitter thinks it's putting out 4 million, but the SEM54 says, well, no, I'm reading 4.2. And of course, the calibrator is going to be at least 4 times as accurate as the device it's testing. So this is the number that we're going to go with. So what we need to do next is we need to tell the transmitter that it's out of spec and have it pretty much repair itself. So we're going to fetch that 4.2 milliamp value, and then we're going to send it to the transmitter and tell it to fix itself. And it does. You'll notice now it's putting out 4 milliamps. We'll continue to the 20 and do the same thing. You'll notice it thinks it's putting out 20, but it's actually putting out 20.2. So we'll fetch that value, send it so that the transmitter can correct itself, and we're done. Next, we can do the sensor trim, and we'll enter here. If we have a dry well in the setup, we could use that, but we don't. We're just using the output of the SEM54, so we'll go ahead and do that. We're going to do both the upper and lower values. Okay, next source. Okay, lower range value is 0. So we're going to set that in trim. Device malfunction. I'm wondering if give me a second. What's the drywall? Okay, let's try it again here. Sometimes these transmitters don't work the way we want them to. We'll hit lower range value. And hit trim. And so it's going to set that lower range value to 0 degrees C. Once complete, and we're going to continue and go to the upper range value, which, if you remember, is 300 degrees C. So we're going to set that and trim. And once that is done, we've completed our sensor trim. We've hit the low end, the high end. Okay, and we're done. So now we're back to the main screen. So we've done our as found, and we've recorded the readings. We've made our adjustments, and now we're going to perform the as left. So this is as you finish up your calibration. You've done your initial test, you made your adjustments, do the as left. We've got our same configuration information that was downloaded from the software from ProCal here. And then we'll do the Autotest. So again, it's going to repeat the calibration test at the 5 different strategy points. Go from 0 to 75 to 150 and so forth. And it's now capturing. If you notice, you're starting to see some numbers that look a little bit better than before. And we're not going to see the inverse video anymore if we've made the adjustments, which it looks like we're doing a pretty good job here. So again, once it's completed with the as left test, this information will be captured in the calibrator. And all this is important data, because this is what gets sent back up to the ProCal software and gets populated into the database. So as you notice now, we've completed our test, and wow, look at the error percentage now. We are pretty much right on the money. Okay, so we're well within the spec. We're in good shape here. We'll continue. Again, it's going to record that same data. The tag ID number, the SIL number, who did the test, and that's it. So we'll continue, and then it says, okay, the final message that can be put in. If there's a message for the tech, let's say to turn lights off or close the box, whatever, that's done. So now that information has been captured into the calibrator. And if I review memory, you'll see here's that calibration result. Now remember the report that Mike showed you if we look at this, we have our as found and as left results. I'll enter in on the as found, and you'll notice here's all that configuration information that you see in that calibration report. This gets saved. And then if we go to the next page, you'll see that as found data. So here's all that stuff that was out of spec, and this gets documented, saved to the software, so it can be reviewed later. You know, wow, this thing was out of spec when you first went out and looked at it. When you're completed, then you go down to the as left, and again, this gets captured as well. You'll see here's the configuration information. Go to the next page, and there are your as left results. So this calibration has been completed. This transmitter is back in service because it's looking good. But you have all this data has been captured and has been sent up to the software. So yeah, that's pretty much it. I'm going to go ahead and stop the share here and give it back to you, Mike.
Thanks, Bob. Thanks for the demonstration. And, you know, like Bob said, from that point, it's as simple as plugging that calibrator into your computer, your ProCal workstation with the USB, going to the upload screen in ProCal, uploading those results. Again, you can look at each result one by one, or you can approve them as a batch. It just takes you 1 or 2 clicks to get to that calibration screen that we saw, or the calibration certificate that we saw before. So just reshare my screen so you can see some of our contact information. And this is a period where we'd like to get into the Q&A and answer some of your questions. I see that we've already had a few. So like I said, my contact information is on the screen there, my email and my phone number. Can reach us anytime, and Bob's email is also up there if you have any more hardware specific questions for him. So let's answer our first question. Came from China, China Casper. Thanks for your question. Bob, I think this is for you. Our maintenance department is wanting to get a 753 instead of a 754 because they said it is extra cost to update the heart every so often with the 754, and they did not see the value in that. Is there any value loss with the 753 specifically when dealing with calibrations with ProCal?
Good question. Yeah, the 753 and 754 are the exact same device, except for the 754 does have, it adds heart capability. So you can talk to most every device heart and get the basic heart communication calibration wise. And it also supports some of the most common heart transmitters. But if you want to do full heart, let's say commissioning, for example, then I would recommend pairing up that 753 with a Fluke 154 communicator, which that supports the entire DD library. And and I'm not trying to sell anything, but you do get free quarterly updates with the Fluke 154. So yeah, that'd be a great add-on to the 753 if you don't want to do a direct heart calibration like we just did with the 754.
Thanks, John. We have another one here, Bob, for you from Jonathan. And this is, could you address a calibration with a loop-powered device and taking a reading from a host system such as a DCS?
If you are, it sounds like what you're doing is you want to measure the milliamp output and also possibly source into that device and maybe take the reading off of the PCS that's connected. Now, what you can do is set the 754 up to enter user defined values. So you wouldn't necessarily look at the milliamp output of the device, but you would look at what the DCS is reading. And then you can enter that value into the 754, and that's what we call a user entered value. So yeah, you could do that. And I think that's what the question was. It was hopefully that does it. Okay.
Thanks, Jonathan. Got another one here from Ryan McBrearty. How many tasks can be stored on the 754 at one time?
Tasks themselves are they're not very memory. They don't use a whole lot. Let's put it that way. And but so conservatively, I would say probably around 50 tasks to be downloaded. But again, it's always recommended that after every day of calibrations, you bring the 754 back up to the shop and give it to the admin to upload those test results. So normally I would guess 5 to 10 calibrations a day is probably pretty good. A super tech like Mike, of course, could do like 20, but yeah, it holds quite a bit.
Cool. Thanks, Bob. Got a few more here. This one's from Dion. This is what protocol is used to talk to ProCal for the Fluke device?
It's actually a proprietary protocol, so it's not something that's open source. So there's it's not something you could actually look at, like from a terminal emulator or something like that. It's proprietary for the software and the calibrating.
All right, we have another question from China, follow-up on the 753. Would the 753 be able to perform the trim like you showed with the 754? Would we have the full capability to download calibration from ProCal to the 753, performing the calibration as you demonstrated?
Absolutely, yeah. So what you would do is you would just do your as found and your as left from the calibrator itself. You wouldn't do the adjustment from the 753. What you would do is you would, if you had your communicator set up there, you would actually do the adjustments from the communicator separate from the 754 itself. And you could, from the 754, you could apply manual settings. Like you could say, okay, go to 0% and then go to 100%. And then you could make your adjustments that way. So the heart adjustments are not captured by the 753, and the software doesn't care about that. The software cares about those as found and as left test results. So yeah, you should be in great shape using communicators such as the 154 to make those sensor trim and 4 to 20 milliamp trim adjustments.
Great, thanks, Bob. Thanks, China, again for your question. We have an anonymous question here. I've been advocating to move from a paper-based system to ProCal, but I've been getting some pushback from higher-ups. How much time would you expect I could save moving to the Fluke ProCal solution? So we did briefly mention that during the presentation. We've done some analysis both here at Prime and Fluke that's shown that those numbers can be as high as 75% of the time can be reduced when you're using a calibrator as opposed to a paper-based system. And we also here at Prime, we have a case study coming out here shortly in the near future that has some real specific numbers and analysis done on that type of time saved. So keep an eye out for that. We'll be putting that out shortly online. We have another question here, and Bob, this one I don't think we touched on, but if we have a pressure module that we use with the 754, how does that get entered and logged on the calibration result?
Oh, okay, yeah. So as a matter of fact, we've got pressure module right here. So, so we've got, we've got like 50 different pressure modules to use with the 754 in a calibration. So what you'll do is if you're doing a pressure calibration, you would hook up your pressure line to the pressure module to actually end with a pump, and you could actually measure what is being sourced to the device. And then through the cable, and this is about a 2 or 3 foot cable that's wrapped around here, but this connects right up to the 754, and that is digitally, that value is digitally sent from the sensor. So this is again, a highly accurate pressure sensor, which is taking that pressure reading when you pump the pressure into the device. So you can do a calibration with the 754 and a pressure module based on that setup. So again, you can't. I wouldn't recommend doing an automatic calibration with the 754 when you're doing pressure, because if you say, okay, 10 seconds, that means you got to pump that thing up to 10 seconds, right? In 10 seconds, and it's I'd recommend doing a manual test, and that way you can get your, whatever, if you're doing a 3-step test, maybe going 0, 50, 100 PSI. You can manually enter each value as you get to that pressure. If you go from 0, you look for the 4 milliamps, go to 50 PSI, get your 12 milliamps, and then pump it up to 100 PSI to get your 20 milliamp reading. So you're doing the same exact calibration test, but you're using a hand pump. Now, if you were to use the 729, now we're back in the mode where you've got an internal sensor in the calibrator. The 729's got an automatic pump, regulator, and reservoir. So it automatically does that test for you. Again, it does similar to what we just did with the temperature, but it is definitely made for doing the pressure calibration.
Great. Thanks, Bob. We have another question here from Darcy. Is ProCal able to push calibration certificates to SharePoint? ProCal is absolutely able to export those certificates in an electronic file, whether it's a PDF or Excel spreadsheet or HTML. There's many different standard formats that you can export those out. Now those can be sent to SharePoint. We've looked at integrations with SharePoint to do some automatic export, but most of our customers, if they do want to export those files outside of the system, we'll send it in a PDF and then upload that to SharePoint directly. So, all right, I think we're just about out of time here. Thanks again, guys, for all your time today and for your questions. We hope that the session was helpful and broadened your understanding and how ProCal can reduce the amount of time spent on performing calibrations while also improving the accuracy and reliability of records. Like I said, our contact information is up on the screen there. So myself and the whole PrimeTech team are available, via phone or email to answer your questions. And we really look forward to speaking to you in the future. Thanks again and have a great day, and hope to talk to some of you soon. Thanks, Bob, for all your help today.
My pleasure. Thanks, sir.
Have a great day, guys. Thanks.